right, so for this first one, what is tricky or more difficult about this question is they don't give you the formulas for a circle and a cylinder. You're expected to know those ones. If it's, a cone or a sphere or something strange, they may give it to you, but circles or something like a cylinder, they're not going to give you these formulas. So let's read through this. So consider all right circular cylinders, just to give you a visual, not that we're going to really need a picture here, but this is what a cylinder is when they say that, like a Campbell's soup can. It says the sum, so that means adding, of the height and the circumference is 30 centimeters. They don't give you the formula for circumference of a circle. That's, this amount the whole way around. So circumference of a circle is 2 pi r, and they would expect you to know that one. Okay. So sum of the height and the circumference is 30. What is the radius of what, meaning a cylinder, with maximum volume? So volume is what we're trying to optimize, and so we need an equation for volume of a cylinder, which again, they did not provide. So volume of a cylinder is pi r squared h. The pi r squared, that's the area of the circular base. This is pi r squared. And then times the height of the cylinder. So this is your volume, pi r squared h. So the issue with that is there's two variables. There's r and there's h. So we need to substitute one of them out. And so you go back to the problem and see what other information they gave you, which they gave you right here. The sum of the height and the circumference is 30. So if we add the height plus the circumference, which is 2 pi r, that is going to equal 30. And so we need to solve for one of these variables, and it's going to be a lot easier to solve for h. I'm just going to subtract over this 2 pi r. And so that is going to get substituted in for h over here. So we're going to have volume equals pi r squared times all of this. And so we're going to distribute through here. So we'll get volume equals 30 pi r squared minus 2. And then this is going to look a little strange. Pi times pi is pi squared. But don't forget, that's just a number. This is 3.14 squared, which is just some value. And then times 2 is just some value. So all of this is just a coefficient. All right, and then r squared times r would be r cubed. So we had an equation for volume, we substituted out the height, and we distributed through there. Now it's going to be derivative equals 0. So this derivative, bring the 2 down, that'll be 60 pi r. It drops from a 2 to a 1. Minus, and then we're going to do the same thing here. This 3 comes down. So 3 times 2 would be 6 pi squared. And then it drops from a 3 to a 2. That's our power rule. And we're going to set it equal to 0. Again, it's derivative equals 0. That's what gives you your critical points, which give you your maximums and minimums. That's what we're looking for. All right, and then we're going to factor this. So we can factor out 6 pi r, and we would be left with 10 minus pi r. So we'd set this equal to 0, and we would set this equal to 0. Now, if you set 6 pi r equal to 0, you're going to get r equals 0, which doesn't make any sense. If you have a radius of nothing, then you don't have a cylinder. It would be like an uncylinder. So that doesn't make any sense. So we're going to do this one. 10 minus pi r equals 0. And then subtract the 10. Negatives are going to cancel, and then divide by pi. So we get r equals 10 over pi. The units were centimeters. That almost doesn't matter because they put centimeters in every single choice. But we want r to be 10 over pi, so that one is E. So what I honestly think was hardest about this question is they did not give you the formulas for volume or circumference. You did have to know those. But other than that, it's no different than ones we did in the notes. You take this and substitute in, derivative equals 0, and then solve it. All right, so for this one, we're going to need a calculator because I see all these decimals here. So we'll need a calculator for this. So a rectangle with one side on the x-axis has its upper vertices on the graph of y equals cosine of x. This doesn't look much like the graph of cosine because they only drew one little part of it, but this is the beginning of the wave, and if they kept going, it would like come down here and then go up here. It would keep doing this wave here, okay? But they only just gave us like one little part of it, just this first bump. So that's the graph of y equals cosine x. We want the maximum area of the white rectangle. Now I already drew in here like what x and y are. This distance is x and this distance is y, because I was going over this during office hours. So this is x, this is y. We want the area of the white rectangle, which is going to be 2x times y. So it's, you know, base times height or length times width. It's just, we're doubling the x's. Like this is x and this is also x. So the whole thing is 2x. So our area is 2xy. And so the problem is we have two variables. We have an x and we have a y. So we have to substitute one of them out. And they gave us y equals cosine of x. So that's going to get substituted in for y. So I took out y and I put in cosine of x. And now it is derivative equals 0. Now I have two separate functions here. We have 2x and we have cosine of x. So I'm going to throw a question at you guys. Hey guys, what rule do we need in order to do this derivative? What derivative rule is this going to be? Good, nice job guys. Product rule, all right? So product rule is the first function. You guys rock, thank you. All right, first would be 2x. Derivative of the second, all right, derivative of cosine is negative sine, all right, plus the second function times derivative of the first. And we're going to set this equal to 0. So here's where the calculator comes in, because I can't solve that by hand. So if you want to follow along with me, in your calculator, we're going to go to y equals, and we're going to type in all of this. So 2x times negative sine of x plus 2 cosine x. So I just typed all of this into y1. I'm going to hit zoom 6 for standard. And we're looking at where this equals 0. Now I just did zoom standard, but again, remember we're stuck on this really tiny interval here. It's gonna have to be really, really close to 0. So I realize this graph touches the x-axis a whole lot of places, but we're kind of looking just here. And out of this one or this one, the one we want is gonna be this one. It said we wanted a maximum area, and this is where the derivative goes from positive to negative. It goes from above to below. So this is the value that we want right here. I'm going to do second trace to make my calculator find that. I'm going to choose 0. Now it looks like it's really, really close to 1. So I'm going to make my left bound 0 enter, and my right bound 2 enter, and my guess 1 enter. And it will just tell you, there it is, x equals 0.860. Now here's the thing, if you're not paying attention, this is an answer choice, and if you pick that, it's going to be wrong because we're not finished yet. We still have one more step. Like up here, all they wanted was R, so we found that. If they had asked for the volume, you'd have to take R and plug it back in to get the volume. And that's what we're doing here. It says, what is the maximum area? So you have to take this and plug it back in for this area equation to get the answer. Now, here's the cool thing that the calculator will do for you. This is really nice. As of right now, this second, it has x stored as 0.8603339. Like it's stored that as x. So when you go to plug it back in, when I go to the home screen, I'm just going to type this area equation. So 2x, you can use the variable key, cosine of x. And what the calculator will do is it will plug 0.860 in for x for you, which is nice. So when you hit enter, you get your answer. So 1.122, and so that one is C. All right, so number 3. Here's our function f of x. The domain is from 0 to 9, so that's our interval. We want the absolute maximum. All right, this is the candidates test. So your candidates are your endpoints, which are 0 and 9, and then your critical points. So to get the critical points, we're going to do derivative equals 0. So this derivative, if we bring the 3 down, the 3 and the 1/3 are going to cancel. That'll just be x squared minus 8x plus 12. So it's derivative equals 0. Again, in unit 5, if you get stuck on any question, just do derivative equals 0 because chances are good that's what you're supposed to do. That's like how all these problems start. All right, so factoring this is going to be x minus 2 and x minus 6. And so these are our critical points. So we're going to make a chart. And remember, you're plugging into the original function. So this one right here. And so we're going to use our endpoints 0 and 9 and our critical points 2 and 6. All right, so plugging in 0, that's going to give us -5. And I have a feeling this is going to get real messy here in a second. This question was non-calculator, so we're going to try and fight our way through this. We don't really need to find them exactly. We just need to figure out which one's the biggest, to be honest. All right. So plugging into 2 cubed is 8, and then times 1/3, so 8/3. 2 squared is 4, times 4 would be 16, so minus 16. 2 times 12 is 24, and then minus 5. So let's see roughly what that would be. -16 and -5 would be -21. Plus 24 would be 3. So this is like 3 plus 8/3, which is like a little bit less. What 8/3 is like a little bit less than 3. So this is like a little bit less than 6. So like, somewhere around there. All right, all we need to do is figure out which one's the biggest. All right, plugging in 6. All right, 6 cubed would be 216 divided by 3. Gosh, I don't know what that is off the top of my head. 216 divided by 3. Sometimes you have to do this, guys, to figure out what your answer is. 72. All right, 72 minus, all right, 6 squared is 36 times 4. 36 times 4 is 144, right? You know what? I'm going to cheat and use a calculator because I don't want this to take all day. Yeah, 144. All right, plus 6 times 12 would be 72, and then minus 5. So 72 and 72 would be 144 minus 144. This is all going to cancel. We're going to get -5. So that's the same as this one here. And then this one's like a little less than 6. 9. All right, if we do 9 cubed, I don't know what 9 cubed is off the top of my head, but that's going to be bigger than any of the rest of these. Like this result's going to end up being bigger than 6. Here, let me type it in just to 9 cubed is 729. 1/3 of that is 243 minus, let me see, 4 times 9 squared. So minus 81 plus 12 times 9 is 108. And then minus 5. Yeah, this is 243 plus 108. Like even if you subtract the rest of this is going to be the biggest one. So 9 is our answer there. So E. I don't like that question. They should have allowed a calculator for that. That was a lot that you had to plug in there. But this one's going to end up giving you the biggest result. All right, number 4. Let f be this function, absolute maximum. All right, so same thing, but they didn't give us an interval. So I'm not going to be able to do a candidate test, but it's going to start the same way. We're going to do derivative equals 0. Because your critical points are still going to be where your maximums and minimums are going to happen. So this one will be a quotient rule. That's the denominator times derivative of the numerator. Let me throw that question at you guys. It's been a while since we've done anything. Hey guys, what's the derivative of ln? Do you guys remember that? I will obviously tell you if we've all forgotten, but does anyone remember derivative of ln? Oh, good, nice, cool, good memories. 1 over x. Nice job, guys. All right, 1 over x. So denominator, derivative of the numerator, minus numerator times derivative of the denominator, which derivative of x would just be 1. So you don't even need to write that if you don't want to. And then over the denominator squared. So your critical points, it's where the derivative equals 0 or is undefined. So we're going to set the numerator equal to 0 and the denominator equal to 0. You could have a 0 numerator or a 0 denominator because it could be undefined. So this numerator, these x's cancel. This would be 1 minus ln of x. We're going to set that equal to 0. And so I'm going to add over the ln of x. And then how do we cancel out ln, guys? What's the inverse of ln? How would I get rid of this? What cancels out ln? Good, nice job, e, perfect. All right, so we're going to exponentiate both sides. These will cancel. And e to the first, or e to the 1, that's just e. Right, so we get x equals e. And then when we do this denominator equals 0, we just get x equals 0, right? So I'm still going to go ahead and make a chart. We're going to plug these in and see which one is the biggest. I actually think 0 is not going to work if I'm remembering this right. Yeah, if you try to plug in 0 here, you get a 0 denominator that's going to be undefined. So you actually can't plug 0 into this function. It's not part of the domain. And then if we plug in e, ln of e over e. ln and e cancel, so that's just going to be 1. So 1 over e is our answer there. So that one is B. All right, number 5, let g be this function. K is a constant. That means k is just a number. For what value of k does g have a critical point at 2/3? All right, critical points are derivative equals 0, and they're saying that happens at 2/3. So that means if you do the derivative at 2/3, you're going to get 0. That is what this means. So if we're going to get the derivative, we're going to plug in 2/3 and set it equal to 0. This one, again, is going to be a product rule since we have 2 separate functions there. So first function, that's x squared times derivative of the second. All right, e to the kx. Exponential is itself, so I'm just copying that down. And then there's a chain rule. You have to chain on the derivative of kx, which would just be k. So it's like the derivative of 3x would be 3. So it's going to be k. So first times derivative of the second plus the second times derivative of the first. So that is our derivative. I'm going to factor that. We can factor out an e to the kx. Obviously, they both have those. And then we can also factor out an x. So that is my greatest common factor. When I take that out, I'm going to be left with kx plus 2. And so what we want to do is we want to plug in 2/3 and set this equal to 0. Now this first factor, exponential, that's a swoop with an asymptote at 0. That is never going to equal 0. It's going to level off at 0, but it will never equal 0. So I'm not going to use that one. We're just going to use this one. I'm going to plug in 2/3 for x and set it equal to 0. So we will subtract 2. And then to get rid of the 2/3, we're going to multiply by 3/2. So we get k equals -3. So that one is A. All right, number 6, how many critical points does this function have? Not what are they, just how many does it have? So we're going to do derivative equals 0 for our critical points. Again, this is a product rule. This is the first function. This is the second function. So buckle up because this one's going to be a bit messy. All right, first function, x plus 2 to the 5th times derivative of the second. So the 4 is going to come down. It'll be x minus 3 to the 3rd. And then there is a chain rule there. You would have to chain on the derivative of x minus 3. But the derivative of x minus 3 would just be 1. So you can put times 1 if you want, but it's just going to be 1. All right, plus the second function times derivative of the first. So bring down the 5. It's going to drop to a 4. And same thing, there is a chain rule, but the derivative of x plus 2 is just 1. So I'm not going to write it. So we're going to set that equal to 0 and then factor it. Now, I know this looks like a horrible mess, but it's only 2 terms. That's the first term and that's the second term. So factoring out, we can factor out an x plus 2 to the fourth, and we can factor out an x minus 3 cubed. Let me go ahead and scribble this out. We'll see what's left. If I take out an x plus 2 to the fourth, if I take out 4 of them, there's only 1 left there. They're all gone from here. And if I take out x minus 3 cubed, all of these are gone, and there's only 1 left here. So let's see what's left. We would be left with 4x plus 8 plus, and then this would be 5x minus 15. Now, I'm not going to do any more work here because I don't need to actually find these. I just need to know how many there are. This is going to give us 1. We would have x equals negative 2. This one's going to give us x equals 3. And then this one, you would have to combine like terms and solve that, but this is going to give you a third one. So we would get 3 critical points out of that. All right, number 7, they're giving us a chart of values for f of x. The function is continuous and differential. Which of the following statements must be true? All right, let's go through these. The minimum value is 2. I realize that the lowest value we see on here is 2, but not necessarily. You don't know what's happening in between these. And in between, it could drop down to negative 1,000,000. So we don't know. Not necessarily true. Maximum value is 4. Again, not necessarily for the same reason. In between here, this could go up to 7 billion. We don't know. Okay. The function is positive from 0 to 4. Again, we can't guarantee that. This might jump down to a negative number in between. All right, D, this is very hard to see. There's a prime mark there. This is the derivative is less than 0. All right, if the derivative is negative, that means the function should be decreasing. So this is the function is decreasing from 2 to 4. Well, at first glance, it looks like it is. This goes 4, 3, 2. But once again, what if in between here, like what if it went 4 and then 9 and then down to 3 and 2? You know, you can't guarantee what happens in between. So it's going to have to be E. Let's read through that one. There exists a C somewhere on this interval where the derivative of C is 0. The reason that's going to be true is we start at 2 and we end at 2. So you have points like this. You have 0, 2. All right, you know what? I'll just plot all of them. So say it does something like this. You start at 2 and you end at 2, so that average rate of change is going to be 0. And so you're going to have an instantaneous rate of change that is 0 at some point as well. Does anyone remember which theorem this is? The one if you start and end at the same place, then you must have turned around, like that's going to have to be 0. Which theorem is that? Does anybody remember? I know it's been like 2 weeks. You're like, why do you want us to remember this? Yeah, good. That one's Rolle's theorem, which is really just, you know, a subset of mean value theorem. If your average rate of change is 0, your instantaneous rate of change is going to have to be 0 at some point. All right, and then last one, piecewise function. We want to find k so that the function is continuous. So that means the two pieces are going to have to meet up. So we're going to set these equal and plug in 2. Conveniently, they already factored this for us, and the x minus 2's are going to cancel. So we're just going to set these equal. And then we're going to plug in 2 for x. And so 2 times 2 is 4, plus 1 is 5. And so that one is E.